This video is going to be part 2 of limiting reagents. I'm going to actually find what the excess reagent is, so how much is left over after a chemical reaction occurs. So I'm going to assume that you watched the first video and maybe not re-go over some of the stuff. So this is part 2. For this, we're going to start off with different equations. So in the reaction, we have 2 moles of silver nitrate reacting with calcium chloride. It will produce, you'll have a double displacement reaction. It'll produce 2 moles of silver chloride and 1 mole of calcium nitrate. So the question is, how many grams of silver chloride will precipitate, so in other words form, when 20 grams of silver nitrate is reacted with 15 grams of calcium chloride? And the part B, which will be on the next page, is going to be determining how much is left over. So first of all, we'll do the limiting reagent. So we're going to start off with our first 2 givens. So we're not going to balance this chemical equation because it's already balanced for us. Let's just focus on our givens. So given number 1, we have 20.0 grams of silver nitrate. Now, right off the bat, because I was given mass, I want to determine what the molar mass is. So the molar mass here, I take my silver, my nitrogen, and 3 oxygens and add them all together. I'd end up with 169.88 grams per mole. Forgive me, I'm not going to show that step because that was lessons from a few days ago. So you should know how to do that at this point. My second given, according to the question, I was given 15 grams of calcium chloride. So given number 2 is going to be 15.0 grams of calcium chloride. So this is a mean question. I call it mean because you're given 2 masses. And whenever you're given a mass, you have to figure out what the molar mass is before you can really do any kind of stoichiometry. So calcium plus 2 chlorines would give you 110.98 grams per mole. Again, you guys can figure that part out. Otherwise, just take me on my word. Now the question wants to know, what is the mass? How many grams of silver chloride will be produced? So silver chloride is going to be produced, so that is what our wanted is. So we want a mass, so the number of grams, if you will, the mass of silver Ag chloride. So again, this one's a little mean because mass is involved, so therefore we have to figure out the molar mass. I probably should have picked a question that involved volume or particles, but alas, here we are. So again, you only need to figure out the molar mass if mass is given to you. So silver is around 107-ish. Chlorine is about 35.45. Add them together, you get 143.32. So when it comes to limiting reagent problems, always start with your first given, right? So start with your first given. In this case, it's going to be my silver nitrate. So write out your silver nitrate. You have, start with what you have. We'll assume that's an AVE. 20.0 grams of silver nitrate. In order to do stoichiometry, we have to convert them into moles. So I wasn't given moles to start with, so our first thing that we need to do is a mole conversion. So mole conversion, so convert. I'm shorthand convert. We'll just call it mole convert. Terrible English, but whatever. So the mole conversion, according to your flux capacitor chart, 169.88 grams. So again, we're just dividing by the molar mass, and I gave you what that is at the top. So again, I'll say it one final time. If you're given a mass, you should probably determine what the molar mass is before you actually do any math. So as I go, I'll cancel units out. So my grams will cancel. And so at this point, technically, I would just have moles of silver nitrate. So now that I have moles of silver nitrate, I can do the mole ratio. So because I can do a mole ratio, I would look at my balanced chemical equation. So the term I want in the end, according to my balanced chemical equation, is going to be a in the end, I want mass of silver chloride, but my mole ratio only compares moles. So I have to look at my balanced chemical equation to see how many moles of silver chloride I actually have. So if I scroll up on my screen, silver chloride, I have 2 moles of that. And I'm starting off with given number 1, so I need to know how many moles of silver nitrate I have, and I have 2 moles of each of those. So that's a lovely 1-to-1 ratio. So the math actually works out pretty nicely in this case. So I have my silver nitrate in the denominator. I'll just erase that, AgNO3. Update your units as you do this. Your moles should cancel out there and there. And while you're updating your units, recognize that with stoichiometry, you're getting rid of your silver nitrate. So that's the purpose of the mole ratio, be able to cancel out your unwanted term. So almost done. We want mass of silver chloride. At this point, we just have moles of silver chloride. So our last is mass, convert moles into a mass. So let's convert into mass. Again, bad English, mass convert. And so for that, we would just have to multiply by the molar mass. So 143.32 grams for every mole. 1 mole. So do your math, cancel out what needs to cancel out. This mole cancels that per mole. And all you have left for units is grams of silver chloride. If you multiply everything through, you will end up getting 16.9 grams of silver chloride. Now might be a good idea to pause the video and try to do it yourself, but in the end, that's what you should get. If you're having troubles getting that number, definitely send me an email. Okay, so that is how much silver chloride will be produced if all of the silver nitrate actually gets used up. So the joys of limiting reagents, you don't know which one is going to actually get used up. So we have to do stoichiometry twice. So now we're going to start with the second guy. So we're going to start off with 15 grams. So we're going to do stoichiometry again. Start with what you have. So use our second guy. So we have 15.0. That's a weird looking 5. 15.0 grams of calcium chloride, CaCl2. Once again, we do not have moles, so we can't go straight to the mole ratio. So we're going to have to do a mole conversion. That's where your molar mass comes in. The molar mass of calcium chloride is 110.98. So we're going to have to multiply by 1 mole for every 110.98 grams. Cancel off your units that cancel. At this point, you have moles of calcium chloride, which is good because now you can do the mole ratio. So I'll try to color coordinate here. So we're still doing the mole ratio. I already know from the previous one, I can see it right above it. I do want silver chloride. So I know from the chemical equation, it's 2 moles of silver chloride. I don't remember what calcium chloride is, so I'll have to scroll up. So calcium chloride has no number in front, which means it would be the number 1. So I have 1 mole of calcium chloride, Cl2. So once more, your mole ratio is handy because it's going to show how one chemical cancels the other chemical off. That mole will cancel that mole, and then you get to proceed. At this point, you have moles of silver chloride. And one of the joys of doing limiting reagents, the last step is going to be the same in each scenario. So in this case, the last step is just writing down, converting my silver chloride into mass. That's the mass conversion. So with this mass conversion, that mole is going to cancel with that mole. And then you just do your math. All you have left for units is a gram and your substance. And so you'd multiply all your numerators together and divide by the total of your denominators. And in this case, you should get 38.7 grams of silver AgCl. So if you need to pause it for a moment, pause it, make sure you can actually get 38.7 grams. If not, again, send me an email. So now that we've figured out both quantities, the amount that actually gets produced is going to be the smaller amount. So that means we're actually going to produce 16.9 grams of silver chloride. So therefore, silver nitrate is my limiting reagent. So my limiting reagents, I'm going to just use short form for this, is my silver nitrate. So that means the silver nitrate is going to get completely used up. And just to drive a point home, only 16.9 grams of silver chloride, AgCl, will form. So that also means calcium chloride is in excess. So let's determine how much calcium chloride is actually left over. And hopefully we can do this in just a few minutes. So I'm going to flip to the next page for that because I think that page is getting too long. So how much calcium chloride is in excess? So that is my very last one. So to do that one, always begin with your limiting reagent. Since we know the silver nitrate got completely used up, let's find out how much calcium chloride was actually used. So we're going to find out the amount that was used. So start off with your actual limiting reagent. So that's 20 grams of silver nitrate. Once more, we don't have moles, so we have to do a mass conversion to convert it into moles. So you end up doing a lot of the same work over and over again in these types of problems. There are shortcuts, but I'll let you figure them out on your own. The grams cancel out, so this is the mole conversion. So now we have moles. Then we do the mole ratio. I'll write it above, it's on a new page, mole ratio. So since we started off with our silver nitrate, I know we have 2 moles of silver nitrate according to my balanced chemical equation. And we're trying to find out how much calcium chloride was actually used. And according to your balanced chemical equation on the previous page, I'll go back for a moment so you can see it again. Calcium chloride has 1 mole, silver nitrate has 2. We have 1 mole of CaCl2. So silver nitrate cancels, mole cancels. So at this point I have moles of calcium chloride. I was given mass of calcium chloride. We started off with 15 grams of calcium chloride, so that means we should do a mass conversion in order to figure out how much mass is left. So from the molar mass, we know that the mass conversion is going to be 110.98 grams for every 1 mole. And then we just finish off with stoichiometry. I'm going to cancel my mole there with my mole there. All I have left for units is grams of calcium chloride. You do a little bit of the math, multiply all the numerators, divide by all the denominators, and you should get 6.53 grams of calcium chloride. So that's how much was actually used. Remember, we have, according to the question, 15.0 grams. We used, so we're going to subtract what we used, 6.53 grams. So then we just do the math, and our leftover in excess, we should have a 8.5. I'm going to call it 8.5 and round up because we don't have a digit past that first 0.0, so I'll just round it to 1 decimal place since we're doing addition and subtraction. So 8.5 grams of calcium chloride is in excess. So that's how you can find out how much is left over, or the excess reagent. So this one was a little ugly because every single thing involved mass. You're not going to always involve mass. You will sometimes involve particles, so atoms, molecules, or formula units. So don't be afraid to use those conversions rather than the mass conversions that we did. Sometimes you'll have to find it in liters. Sometimes you'll have to find individual number of atoms. In this case, everything was just mass, just to keep life somewhat simple. And so, like always, try some limiting reagent problems. If you have questions, fire me an email, and I'll help you as best I can. Until then, I'm stopping the video. Take care.